Good evening. Well, I finally am getting around to putting the BNC on the front here of the EICO 324 signal generator for the frequency counter. I have the BNCs, I just kept putting it off, so it's time to mount that, drill a hole and get that in there. And I've got a 10 picofarad silver mica capacitor that I ordered. I ordered 10 of them on eBay there last year, so I'm going to be using that to couple it from the high side of the attenuator. In other words, the attenuator will have no effect on the output of the frequency counter. It'll be like it was on my 324 that I had in my attic workshop. It goes off the high side of the attenuator, and regardless of where you put this or this control here, the fine adjustment, it isn't going to change the output of the frequency counter, and that's the way I want it. So we're going to commence now to open this up, and then I'll get my unibit out and I'll drill. All right, I got the jack in here already, and what I want to do, this is grounded to the faceplate, bolted to and with the lock washer on it, is I want to come before the attenuator with a, in this case, a silver mica 10 picofarad capacitor. That's the smallest I have. Now, when I did mine back in, when I had my workshop, my EICO 324, I had a 5 picofarad in there. I was just guessing at the value. What I've got going into the scope right now, but I really don't have a scope probe. I just got my clip leads going to my Tektronix 2235, the one without the volts per division plastic plates that were broken off when I got it. So right now it's not triggered on anything because I don't have it connected. And I've got about 455 kc going in, and if I connect this lead right here to this BNC, which was on here when I got it, you can see the waveform. It's not a good waveform at all, and I'm wondering if all signal generators are generating that kind of a waveform. I know it's a lot of harmonics, but this is on the low band now, so I would think that, you know, even if I put it down to 150 kc here, which should be right here, you can see that right there. It's pretty bad. Yeah, turn that intensity down. We don't want the intensity too high. That's 150 kc right now, and not quite sure how to use this frequency counter here. I did have it working. It's not showing right now, maybe because I'm not using a scope probe. You know, there's just a direct cable. This is the cable for my little NLS 215 portable scope up there, because it's got the clip leads on it. But anyways, what I'm going to do now is to put a silver mica cap in series with the center lead. Okay, I got it R times 1 here. Alright, now what I want to do is to use this cap over here from the center pin of this jack, which is going to be for the frequency counter, over to the unattenuated, in other words, on the high side of the unattenuated, the attenuator here, the unattenuated part. Here is the output of the signal generator coming right off this tube here. I don't recall what this tube is. I'd have to go in and look in the schematic or pull the tube out. it goes through this resistor here, and then it goes on to the one end of the potentiometer. And so that's the high point right there. So theoretically, I should be able to put my scope right there. And there's the waveform there. It actually looks a little better. Than it does here. That's weird. Let's go to R times 10 here. I think we're on R times 10. I can't see anything here. No, we're still on R times 1. I was wondering why it didn't change. Alright. Let's put the sensitivity up here a little bit. There we go. Okay, we got the frequency counter going here. 149.81. Okay. Alright, let's shut that off. You see, when that's going, it pulsates, see it? When that frequency counter's off, well, I think it's off. All buttons out, frequency counter's off. Alright, but there's your waveform. I can't see anything. Where's my trigger level here? Here it is. Alright, there's the trigger points right there. Hit. Okay. Okay. But that's not a very good looking waveform. And we get a better looking waveform over here. If I can get this to clip on there. And actually a higher one. It's a lot better looking. Not perfect sine wave, but it is looking better and more amplitude. So that's where we want to come off of with the capacitor going to here. Now, here is something that I was wondering about too on this signal generator. According to the schematic, take this off of here a minute. According to the schematic, there is no coupling capacitor to the RF output. Now, I got this, Don gave me this. And he put the BNC on, which is what I like about it. And the schematic does not show a capacitor here. I'm wondering if I should take a capacitor and put it here. But if I use a 10 picofarad, maybe too small, but we're working with RF frequencies, but the lowest frequency that we're using on this is 100, it goes down to 150 kc. So 10 picofarad might be too small. We could probably use like maybe 001, but it wouldn't be a silver mica. These happen. I got this special for the frequency counter jack, so I think we may be okay with that. But maybe for a DC blocking capacitor, it may be a good idea for me to take out this wire here and add a capacitor here. But first of all, what I want to do now is I'm going to put clip leads on it, which is going to show a lot of stray capacitance. But I'm concerned with this working on this jack here. Now, this is not the right way, of course. You really need very short leads. But I need to do this in order to take this capacitor and insert it in here to see if it will change this waveform, and I think it will. It may be so weak that it may not even trigger the scope, and I would have to drop my volts division down even lower. So the only way to find out is to put this capacitor in here. Now this, as I said, is going to be for this jack. And there goes my phone again. I'm going to let it go because I've got the intercom. If my wife needs me, she calls me by the intercom now. Okay. Note the amplitude of the waveform, the height of it. Okay? We're going to put this capacitor in series here. I've got to put the camera down to do that. This is a 10 picofarad silver mica. Quite a drop. Quite a drop. And of course we're getting stray capacity here and everything from this. But there's no way I can get in there and get that to stay in this way, so this will probably have to do. What I'm going to do now is leave this in place, and I'm going to bring this probe up to my frequency counter. Okay, we didn't touch the frequency, the signal generator. It's 149.804 kilocycles. And it should be the same on this one here. Yeah, very close. Not right on, but pretty close. $149,824. 149,824. 149,832. But you can see the amplitude dropped enormously on this. And it's got a thick pattern here, and it's not focused. That was not that way. Let's drop this down one more here. That was not that way when I connected it direct here. Now I'm attributing this to this here, because this is only a test. So let me pull this out. There's no danger of getting a shock here. We're working with the RF output. We're not working with the B+. Let me see now if I can get this. Let me see if I can get this to touch in here. That's the question. I'm near it, but I'm not coupling on it. Getting capacitive coupling here. I can't get that. I can't see to get it on there. I had a good waveform. It almost had it. Well, not as thick, but still a little thicker than I think it's distributed capacitance is what it is. But the question is this capacity going to be too small for this? 5 picofarads is what I used on my other one, and I was able to get signal generator output reading onto my frequency counter without any problem whatsoever. And that's where you want to come off, is right there. There's a resistor here. Let me give you the value of that. Hang on a minute. It's blue, gray, and black, so that would be 68 ohms. This thing is older than a lot of you viewers out there. 68 ohms. That's what this is right here. That's coming off the, I think it's coming off the cathode. I'm not sure if that's a cathode follower or not, but I have to look at the schematic. Okay, so that's the high side of the attenuator. So you want to be right here. You don't want to couple into here, because I think I'd probably throw the frequency off. It's not much resistance, but it's probably an isolation resistor, and that goes, I think one end of that is grounded. The top terminal is grounded. The slider goes down Is that a disc capacitor I see in there, or are my eyes playing tricks on me? Yeah. Yeah, I think there's a disc capacitor in there. It sure is. Off the slider. I did not even see that. Alright, so there is a capacitor. I don't know what the value of that is. I'll have to look into, go in the house and get the schematic, because I do not have that printed out. I thought I did, but I don't have the schematic of this. The simple reason is that I was given this, and I didn't need the schematic. I didn't need to do any service, because Don went all through this. And the only thing I wanted to do is to add a jack for the frequency counter like I did in my other one. The capacitor comes off the slider, goes down here, and goes to the attenuator switch, and then out from the attenuator switch to the main output, the lower jack here. So I will need a capacitor if I want to come off the fixed output, in other words, the unattenuated side, which is right here. So I will need to put a capacitor from here to here. What I think I should do is to find out what that disc is, what value that disc is. How's that sound? Okay, that capacitor is 1,000 micromics, so that would be 001, 0001. I gotta go look at my chart. And the resistor is a 68 ohm. The print is very, very hard to read. I downloaded it, but it's smudgy, and you know how that is. You can't read the value. Like, that's supposed to be R7, that's 68 ohm resistor, but it's very, very hard to make out the letter R, but you know R is a resistor, so that goes without saying. So anyways, that's what that is. That's R7 68 ohm right there. And the capacitor that comes off the slider of this is 1,000 micromics. And the other end of this pot is grounded. And the output is off the cathode. So I would say it's cathode follower, pretty sure. Remember I guessed that maybe I should use a 001? But I gotta look at my chart, my cheat chart here. Okay, 001, right down at the very bottom here, 0.001 microfarad, or MFD, did the same thing. Here it is, right in black and white. We had a little disagreement about that. Microfarad, UF, and MFD are the same thing. But anyways, 1 nanofarad, 1,000 picofarads. So I need a 001 in order to couple the frequency counter properly to the jack here, and hopefully not lower the waveform. You can see how the amplitude was way down with the 10 picofarad capacitor that I had in there. So it's a 0.001, and I'll have to look and see if I got one that's small, like a disc or something. Here is a 500 picofarad, a disc, because I don't really want to put in one of these larger 001s. like these here, probably would be okay, but you probably want something physically smaller. So this is half the value of what it calls for than what was in here, but I'm doing this here from here to here. So I think if I put this in here, I probably won't get as low of an amplitude output. I'm going to test that amplitude right now. The scope is still on. What you're hearing is the fan. It's kind of howly in here, a little bit noisy. This is the scope Mike gave me. Works very well, except for, like I say, the volts per division. I have to count over from the extreme right over in order to see where I'm at. Okay, so let me get hooked up here, get this in line, and I'll be right with you. Alright, and a hell of a time getting that in there. Can't see what I'm doing. But I got the 500 picofarad in here. Like I say, calls for a 001 on that one back there. So this is a little larger than the one I was going to put in, you know, the 10 picofarad. So now we got it in there. Now we can get our scope reading right out of here. Okay, I just turned the generator on, so we got to wait for it to come up here. And we got a piece of wire stuck in the BNC jack and the other end grounded. And here's our, looks like we're getting the full height that we get before. Now, there should not be any effect on these here, or very little effect. There is a little movement here when I turn this, because part of this goes to ground. One leg goes to ground. So you're probably pulling a little signal down to the ground when you do that. Okay, but that's all right, because the main attenuator here is doing very little to the trace. And the waveform looks a heck of a lot better. So now what I'm going to do is let's check the output down here. See, that's the output down there. Certainly don't look too pretty over there, does it? Now remember, that's running to a capacitor that's buried in the back. That's 1,000 Mickey mics, or 001 microfarad. And this is a 500 picofarad, so I think we're okay on this. Now, we're going to put the frequency counter on this right now, and we'll give that a try. Okay, 150 kc. This is always confusing because I never know. It reads different on every position. I don't trust this. It was reading good before, but I believe the frequency counter. It's 150 kc here. And this thing here, for some reason, this is very, very confusing to use on this frequency counter. Very, very, very confusing. Sometimes it'll read right pretty close, like it did earlier today. I don't know. We'll just turn it off. All buttons out and turn that off. Maybe it's not working right, I don't know. It's nice to have a frequency counter on the scope. But anyways, you can see the horrible waveform we're getting here. But we're getting a cleaner one for the frequency counters, and that's important. So we know that works. Now let's put some modulation in there. Alright, here's your modulation. There's your modulation right there. There's your modulation. I believe this is 400 cycles. Alright, and then there's your RF. So by doing this way, it isolates it, and you get the maximum signal out of this, and you can have your frequency counter connected up here at all times. So that concludes this test. My only other complaint on this now is, shut this scope off here, is this dial light. I replaced it with a 44, gives them a little more light. It had a 47 in here. But there is virtually no light here at all. No light whatsoever, and you can see a little here. The one I had in my workshop, in the attic, both sides lit, and it was only one bulb. You can't really put another bulb in here. You see how bright that is? Actually, it's much brighter than what it shows on the camera, I think. And there is no adjustment in and out. I mean, it's the bracket where the tuning capacitor is on is screwed right down in here. And I need to get more light on this with my eyesight. I need to get this lit up. So let me turn the lights off in the shop here. Okay, that, in my eyes, are very, very, very hard to see. There's more light here than there is here, but I can't really read that. You see, there's like a silver coating on this plastic, and then this is the dial right here, the aluminum dial. So now maybe they made different models. I don't know. The one I had was a 324 also. Maybe it had another light up here. I don't know, but it's not a biggie. But it's nice if I can get more light. But I'm very happy to get this in, and that's important. So I just put a little label on that. So I think we're done with this. So that's the story here. If you want to do your signal generator and you want to put a dedicated jack on there, I would probably say use a anything from a 500 picofarad cap to 1,000 picofarad cap, ceramic disc or silver mica, in series with the output center connector here, and connected to the unattenuated portion of your fine and coarse adjustments.